Good morning, everyone. It gives me great pleasure to welcome you all to the inauguration ceremony of the Electric Vehicle Workshop, organized under the banner of the IEEE Power Electronics Society Day celebrations by the IEEE Power Electronics Society Student Branch Chapter HBTU Kanpur, in association with IEEE Power Electronics Society UP Section and IEEE Student Branch HBTU Kanpur, and IEEE Women in Engineering Affinity Group. This workshop marks a step towards understanding the future of clean and intelligent transportation. Over the next 2 days, we will dive deep into the evolving field of electric vehicles, learning about their systems, design innovations, power electronics, and the technologies shaping tomorrow's mobility. This workshop is designed to offer not just theoretical insights, but also a practical understanding of how electric vehicles work. It aims to connect classroom learning with real world applications through talks and interactive sessions led by industry professionals. We are honored to begin this event in the presence of distinguished faculty members and mentors. I'm delighted to welcome Professor Dr. C.N. Singh, sir, Head of the Electrical Engineering Department, HBTU Kanpur, sir. Sir, your support and guidance continuously inspire us, and we are grateful to have you with us today. It is also my pleasure to welcome Professor Dr. Sanjeev Kumar Sir, Counselor, IEEE Student Branch, Faculty Advisor, IEEE Power Electronics Society Student Branch Chapter, and Advisor to IEEE Women in Engineering Student Branch Affinity Group, HBTU Kanpur. Sir, your mentorship has always been instrumental in empowering the student community. Before we move ahead, let us invoke the blessings of Ma Saraswati, the goddess of wisdom, knowledge, and learning. I request everyone to take a moment, close your eyes, and mentally recite the Saraswati Vandana, allowing the spirit of knowledge and clarity to guide us throughout this workshop. Well, there happens to be some network issue. Just hold on a minute, everyone.
No issue, it happened in online mode. Don't worry. चलो
या कुन्देन्दुतुषारहारधवला शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना वन्दिता सा मां पातु सरस्वती भगवती या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्कर प्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमाम् आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीमभयदाम् जाड्यान्धकारापहा हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदाम्
Thank you. Now it is my privilege to introduce the leadership teams behind this event. The student office bearers of IEEE at HBTU Kanpur, whose dedication and hard work have brought this event to its life. IEEE Student Branch HBTU Kanpur, we have Chair Ms. Jasmeet Kaur ma'am, Vice Chair Ms. Kanika Pandey ma'am, Secretary Mr. Anushesh Pandey sir, Treasurer Mr. Pankaj Yadav, and Webmaster Mr. Satvik Bhatnagar sir. For the IEEE Power Electronics Society Student Branch Chapter HBTU Kanpur, we have Chair Mr. Ashutosh Yadav sir, Vice Chair Mr. Deependra Singh sir, Secretary Ms. Neha Arya, Treasurer Ms. Unnati Anand ma'am, and Webmaster Mr. Udit Gupta. For the IEEE Women in Engineering Student Branch Affinity Group HBTU Kanpur, we have Chair Ms. Unnati Anand ma'am, Vice Chair Ms. Anvesha Singh, Treasurer Ms. Tanvi Sepolia, and Webmaster Ms. Dhruvi Singh. We would also like to extend our heartfelt gratitude to the coordinators of this workshop, Mr. Deepen Singh, Mr. Kushagra Chaube, and Mr. Udit Gupta for their tireless efforts and dedicated coordination behind the scenes. Their contributions have played a crucial role in making this two-day electric vehicle workshop a resounding success. Now, with great respect, I invite Professor Dr. Sanjeev Kumar sir to kindly address the gathering and share a few words to mark the beginning of this workshop.
Thank you, Kushagra. And I congratulate the entire team who is behind this event. And I am so happy and feel very proud that today I have Ankit Bhatt, my student, one of my most favorite batch. My most favorite batch is 2011 batch. And after that, I used to say that 2018 batch is second most favorite batch, and he is from that particular batch. I still remember the journey when we met in second year to final year. Then after, getting gate score, very good gate score, and involve that this MTech program from IIT Kanpur. Then here. So it is very proud moment for me, and I believe that all the participants, however, there are very few participants. I can see only 38, but the registration which I have checked that it is 119. Might be they are watching on the live YouTube stream. That is why they are not here. But I suggest to coordinators that they should mention participant first try to join the Google Meet. Once the limit is reached, means that is more than 100, then they should go for this YouTube link. It would always beneficial and good that we interact directly to expert. In YouTube doesn't provide that much facility, even though they write their comment there and then coordinator will see and tell to expert. But it is great if they join the meet and directly ask their doubt, any question, queries to the expert. And I believe the next 1 hour would be very beneficial for you, because Ankit has vast experience in the field of solar, and he is working starting from his career to from 21, I think, Ankit, if I'm not mistaken, it is from 21 to till now.
Sir, August
Uh,
2020, I joined.
2022 till now he is working there, and he enjoying his job very much. That's I know, according to the conversation we had with Ankit in between. So my best wishes are with you, all the team members, and I hope this would be a great event. Thank you very much. Over to Kushagra.
Thank you very much, sir. Your encouragement continues to motivate and guide us on every step of our academic and professional journeys. With that, the electric vehicle workshop is now officially inaugurated. We extend our best wishes to all the participants for an insightful and engaging experience ahead. Now moving forward to the most awaited segment of today's workshop. It is my honor to introduce our distinguished speaker for the session, Mr. Ankit Bhatt sir, Deputy Manager at the Solar Energy Corporation of India Limited. With significant experience in the energy and electric mobility sector, Mr. Bhatt sir has been actively involved and supporting India's clean energy transition. His contributions in infrastructure development and renewable energy planning are remarkable. Today, he will be delivering an insightful talk on the topic infrastructure of EV charging stations. This is a subject of great relevance in today's world, as electric vehicles are no longer a vision of the future. They are the need of the hour. A robust charging infrastructure forms the backbone of this transition, and we are truly fortunate to have Mr. Bhatt sir guide us through its technical and practical dimensions. We warmly welcome you, sir. The stage is now yours.
Thank you very much, Kushal. So good morning to everyone. It is a real privilege to be back, although in a virtual mode, but back to the college. I have studied in the same classrooms. I have tried to understand various different topics on electrical machines, power electronics, drives, and power systems. So it is actually a really great privilege for me that I have been. And I would also like to extend my heartfelt uh, thanks to Professor Dr. Sanjeev Kumar sir for his generous invitation and for thinking that I will be able to say something useful on this topic. So today, what we will do is basically we will go through EV in a broader perspective. We will try to understand what EV will, how it will impact our mobility sector and how it will impact our power systems. So we are currently in the transition phase, and it is one of the most exciting transitions regarding electric vehicles, because it will combine a lot of different disciplines like power systems, embedded design, data science, and even energy policies. So I had graduated back in 2018, but the world has changed and it is constantly changing. It is changing very fast. So now we are facing challenges that were not faced a decade ago. So how do you charge a million electric vehicles without putting the grid in jeopardy? So we will talk about this. And I would also like to say that there is an update. I will provide a general overview of the electric vehicles. We'll just jump to the PPT shortly. But my intention is not to bury the audience under the jargon of electric vehicles, the technical terms, and I will not discuss any three-phase equations here. So what I want to do is I want to spark the curiosity of the audience about how EV is not just a cool technology, but it is a system disruptor. It can be friends of the power system, and it can be a frenemy of the power system as well. So electric vehicles are about to shake everything we take for granted, from how we generate electricity to how we consume it. So, and how even the cities are going to be planned and how the jobs are to be created. So, if the people think that EV is just about replacing the internal combustion engine ICE with a battery, then they are in for a surprise, because it is going to disrupt the business as usual scenarios for energy and mobility as well. So, we will not focus too much on technical memorizing the acronyms, but rather we will try to ascertain where this wave of electric vehicles is headed, and how the future engineers, which is our audience, how they can ride this wave, how they can, you know, how they can develop a holistic overview for the electric vehicles. So this is my intention, and hopefully by the end of this lecture, you are not going to view electric vehicle as just a vehicle, but rather as an important node in the power system, which is going to interact with the power system as well. With that being said, let's get to the PPT. Wait. So, is the screen visible?
Yes, sir, the screen is visible.
Okay, thank you. So, first of all, I'll start with this disclaimer that the, is the slide also changing? Can you please confirm?
Yes, sir.
Okay, thanks. So these are my own views, and they might not necessarily reflect the official policy or position of my organization. Okay, so this is for information purpose only. So first of all, we will start with the basic definition of what is an electric vehicle. So electric vehicle is a mode of transport, but instead of using an internal combustion engine, we are going to use a rechargeable batteries. So there are basically certain characteristics which are associated with it, that it uses a powertrain, it has an energy source which is
Ankit,
charged. Yes,
Ankit,
sir. Yes, sir.
just press F5 because it is not in the slide mode. So that would be great.
Okay. Okay, let me check.
The same presentation, you just press F5, or at the bottommost right corner, you will see one icon. There you can press, then it will be in slide.
Yes, that is what I was doing. But,
Yes, you just see where, yes, this one.
is it better, sir?
So it is not changing the mode.
It is not changing.
Not changing the mode. because na font is little bit small. Even though it is visible, no issue.
Okay.
But if
Okay.
it is
Maybe I can do one thing.
right,
If you allow me a minute, I'll just convert this into a PDF and
sure. But yes, and no, no, no. You do one thing. You just save it as a PPT show. Then it
okay.
would be displayed. Then directly it would be displayed. You just click this file. File. Just click file at the topmost left corner. Just click next to before the home. Just click file. File icon is there na, file. You just topmost left corner, topmost left corner,
Okay, topmost left.
topmost left corner of your slide, and save
Okay.
as pptx.
Save as.
You just save this ppt. Save as. No. Save as. No option is coming.
Yes, sir. So
No
I just
option is
switched
coming.
to a
Can
PDF
you just
for now.
see whether it is possible,
Yes, sir.
or let it
Okay.
as it is? No issue.
Yes,
No
sir.
issue.
Just a second. I think so does this work? Hello, is this okay?
Yes, sir, it is visible.
Okay,
Yes, sir, it is
thanks.
visible now.
Thank you. So let's start with the basic definition of electric vehicles, and we cover certain characteristics such as it is eco-friendly in nature in the way that it has zero tailpipe emissions. It is cost efficient in the way that it runs, and it is supported by subsidies, incentives, and government initiatives as well. And it requires a mix of skills in power system, power electronics, control systems, and energy management. So basically, what I have done is I've divided this PPT into 6 modules, which will be followed by Q&A session. The time is estimated time is, and so first of all, we are going to cover the power system perspective. We'll briefly dive into what the grid mix it is, what are the RE-rich areas, how the transmission infrastructure is, and what are its limitations, and what are the EVs effect on the distribution system, what are the effects of random charging of EVs. Then we will discuss about using distributed energy resources for charging our electric vehicles, and the ensuing topic regarding bidirectional flow of energy from the homes back to the substation. And we will discuss the load profile of electric vehicles, what is the infrastructure which is required for EV from a vehicle to grid, ancillary services, application. We will briefly discuss what are the ideas on tariff designs for charging EVs using renewable energy, some on load forecasting and the measures to improve. Then we'll briefly discuss in module 2 the policy landscape and infrastructure. What are the domestic policies? What are the state-wise policies? Some case study on Europe, how Europe is pushing its electric vehicles introduction into the streets, and what make in India perspective, what are the raw materials which are available with us, how much we are dependent on imports. Then in module 3, we'll briefly discuss the trends. What are the trends in the price? What is the trends in the battery? What is the global market growth? Why the cost of EVs are falling? uh, Emerging economies like China and Norway, and the transition from ICE to EV, and what are its implications. And the fourth module is on power electronics. So uh, I am sure that Sanjeev sir is going to cover this in detail. So I will just briefly touch upon the components. And lastly, in module 5, we will discuss what are the environmental and social impacts of using electric vehicles. So moving on to module number 1. So, so first of all, let us discuss about renewable energy for electric vehicles. So electric vehicles are not zero emission unless you use renewable electricity for it. So suppose our grid is heavily dependent upon coal, then there will be emissions. The emissions will be transferred, will be outsourced to some other location, but the emissions are going to happen nonetheless. So in consideration of the environmental footprints, it is also suggested from a renewable and sustainability perspective that renewable energy should be used for charging our electric vehicles. So briefly, I want to introduce this concept of high capacity electric vehicle hubs and fleets. So in time when the penetration of electric vehicles is going to increase on our transportation, then what we will see is there is an idea of having centralized locations where many EVs can charge at the same time. So what are the characteristics that are expected of such hubs and fleets? So they will be massive. They will have a high power demand from 5 to 20 or more megawatts, and they will have to have certain dedicated feeders, provisions of smart charging, and the transformer capacity should also be there. So, and this must be included in the urban planning, the city planning, and there. And we will further discuss in the ensuing slides the time of day tariffs, the capital support, and the green sourcing norms which should be required for such high capacity hubs and fleets. So this is just an idea for everyone. So next we will briefly overview what is India's electricity mix. So the final quarter of financial year 2024 to 2025, India generated around 512 billion units. So as you can see, the percentage share of coal is the maximum. So Indian grid is still highly dependent on coal, as well as the most generation comes from the thermal sources. So these things have to be considered when you are thinking of charging your EV from the grid. So we will briefly see what are the Indian states where the most renewable energy is produced. Top states are Rajasthan, characteristic of such states. Such states are located in places is very low, where the land can be had cheaply. And so one thing we can observe from seeing the locations where renewable energy is produced is that they are not going to be the centers where electric vehicles will be. Electrical vehicles will be driven in urban centers, metropolitan areas, places with high energy density. So naturally, what we have to do, we have to transport this renewable electricity to the areas where renewable energy is, where the EV renewable energy for electric vehicles is going to be consumed. So, so this is just a basic slide on capacity utilization factor, which we call as CUF. I'm sure that the students will study this in power systems. So basically, CUF is what is the maximum capacity wise energy that can be generated compared to what is the actual energy that is generated. So you will see in the news that more than 100 gigawatt of solar energy has been installed, has been commissioned, but the energy that a 100 megawatt of solar power plant will produce will not be equivalent to the energy that a 100 megawatt of thermal based generation plant will produce. So here is a table which shows the typical CUF range for different plants, right? So what I want to tell through this slide is you have to consider the transmission lines that will be built to evacuate the power from high RE areas to low RE areas. So these transmission lines are going to be used for a small percentage of the time only. We take the example of solar PV resource, photovoltaic resource. So it will generate electricity only during the sunshine hours. But the transmission evacuation system has to be dedicated for it nonetheless. And the transmission evacuation system is not going to be used when the solar plant is not generating electricity. So this is a limitation where there is a low average utilization of transmission line. So one thing to keep in mind. Next, we will discuss this Dirk curve. So what we do is, suppose we plot the load of the country. So we will see that there are certain peaks at the time of evening and at the morning time. But in the day, when the solar is generating, the net demand is going to be low because renewable energy resources like solar will be generating during these times. So during the time when there is a high peak in the grid, at these times the grid is the most vulnerable. At these times, uh, there should be, what we try to do is we try to shed the load so that the transformers, the transmission lines, they the transmission lines do not cross their transmission capacity. So at such times it is required that the load should be less, and at the daytime it should be required. So if this curve would have been more flat, the power system engineers would have been more happy. But that is not the case. And what is the trend that is developing is that the belly of this duck is going down and down, and the neck, which is the steepness at which the rise of demand is there, it is increasing further. So these are certain challenges that the grid faces. This is also one of the concepts that we will have to keep in mind while we discuss EVs. Next, we are going to talk about what are the RE transmission infrastructure limitations. As previously told, that the renewable energy uses transmission lines to a lesser degree, to a lesser percentage. So what we are seeing right now is the renewable energy expansion is outpacing the transmission infrastructure development for our country. Especially in areas like Rajasthan and Gujarat, it is very difficult to get transmission evacuation. Because of these reasons, the renewable energy growth is also slowing. The tenders for renewable energy are sort of on hold until the transmission delays are taken care of. So, so this slide covers basically the transmission delays which are happening. If you look at the areas like Bhadla, you cannot get connectivity before 2029. There are stalled RE corridors. There is grid congestion also because of renewable energy. Because in the daytime, when there is a peak of renewable energy generation, these lines are congested. So what happens is they have to curtail the RE plant from generating to their maximum capacity so that there is not a situation of grid congestion happening. And then there is infrastructure gap, so transmission lines have to be built much faster, but it is a process, and certainly it takes time. So So through this slide, what I was trying to tell is that the evacuation of renewable energy from RE rich areas to the areas where EV will require renewable energy is already constrained, and when RE rich areas try to transport to EV hotspots, then it will create more evacuation constraints. So this is the same slide on evacuation limitations. So certainly new infrastructures need to be built, and the so it is already congested. So what is required is transmission planning. So EV charging hubs, which will be on highways and other areas, which were previously low load zones. So this requires certain studies on the part of the transmission planning, how network should be expanded, how the load flow and short circuit analysis, and the SCADA and real-time load monitoring should be there. So from the engineering perspective, so there is requirement of upgradation of our transmission planning to accommodate renewable energy for electric vehicles. So now we switch on to a different topic, that if we cannot transport renewable energy from far off places, from the rich places, then why cannot we generate the renewable energy locally? So here in this slide, DER stands for distributed energy resource. So, so suppose that we use local solar panels. As you may have seen that the rooftop solar panels are becoming more and more common, and they are also being incentivized by the government through schemes like PM Surya Ghar. So, so there are certain benefits of making the local generation for the renewable energy for our electric vehicles. So first of all, it reduces our dependence on long distance transmission. It eases the stress on the national grid. There will be lower transmission losses, and this deployment will be much faster because there is no need to set up different substations and transmission evacuation system or even solar power plants, because the solar rooftop and local sources of renewable energy can be installed much faster than the utility scales. So if we are to seriously consider using distributed energy resources for charging our electric vehicles, then the enablers would be battery, because it will require a battery energy storage system, because sometimes maybe the renewable energy is there but vehicle is not available for charging, or maybe in other times vehicle is available for charging but renewable energy is not available. So in such cases battery will be required, and there will be also requirement of a charge management system, because you would like to charge based on the RE availability and the time of day as well. But of course, such concepts also present certain challenges in terms of the space limitations for solar setups, because the space is can be a constraint, and the capex requirement for a solar EV charging and storage is also going to be significant. So through this slide, we are looking at what is the suitability of different RE sources for local generation of renewable energy for our electric vehicles. So, so here solar energy appears as the most promising, the most stable and suitable ones when it comes to certainty of availability, because 330 days, 300 days in India we have adequate sunshine, and there is flexibility of installation. There is also incentive by the government. There is you can have it on the top of the EV charging station, and there is also suitability for coupling stations through open access. So open access we will discuss in the later slides. So suppose that we allow more and more distributed energy resources into our distribution network. So what will be the consequence of that? Suppose that I am having a solar panel installed on my roof. So the excess energy that is going to be generated from my roof may go to my neighbor's home or may go to anywhere in the in the network as well. So what was usually the case that the distribution network used to have traditionally only one way flow of power. The power used to flow from the substation to other people's home. But now there is going to be a bidirectional flow of energy, meaning that the energy will from your home to other person's home. So or maybe so so in that case there is going to be a bidirectional flow of renewable energy. So what are the requirements for such systems? It requires smart meters. So if any of you have installed solar rooftop in your homes, then you will know that your meter has to be replaced with a smart meter so that net metering can be done. And other smart grid technologies will also be required. And so what happens if there is a very large scale rooftop installations? Currently, subsidies are also available till 5 kilowatt of rooftop only. So what happens if large rooftop installations are installed? Then the DISCOM would also need to strengthen their grid infrastructure, and the distribution transformer capacity would also need to be enhanced, and detailed grid level studies will also be required. So these are some of the challenges that regarding RE that we face when there is bidirectional flow of power in the distribution network. But there are certain, this is a necessary step that is going to happen when more and more electric vehicles are going to come into use, because uh, such bidirectional flow can only facilitate vehicle to grid and home energy systems that are going to interact with the grid. So um, and also I would like to talk about the protection schemes, because protection systems are also need to be upgraded when there is going to be a bidirectional flow of energy. So of course, all in all, there is going to be a requirement of huge infrastructure development, whether it comes to transformer or the transmission lines or protection relays, so that bidirectional capacities in the distribution network can be realized. Now let us look at the charging profile of an electric vehicle. So basically, when an electric vehicle is being charged, there are going to be two stages. The first stage, which is till about 80% state of charge of the battery, is constant current mode, and afterwards there is a constant voltage mode. So so I would like to also put this statement that electric vehicles are not just vehicles, they are power system assets and liabilities, depending on how intelligently they are integrated into our grid. So when we do more and more planning on how more and more EV can come into the place, then we'll also have to design our grid on the basis of how the dynamic loads will be there. So EV certainly makes up for a dynamic load. There are certain factors which affect the curve in which the load profile of the electric vehicle is going to be there. So it depends upon the charger capacity, the state of charge. So basically the what if the charger capacity, it determines how steep and how the load spike will be there. The state of charge will determine that how long high power is drawn. Then the battery capacity will determine how much total energy is required to charge the vehicle, what is the maximum charging rate, and where we are on the curve in terms of our charging profile. And this problem is more and more exacerbated by the fact that all electric vehicles are not going to be of the same make. So there will be different electric vehicles, they will have different factors determining their loads, and when more and more EVs are going to come into the play, then this is certainly going to affect how uh, the load profile will change for the charging of electric vehicles. So, what is the infrastructure that is going to be required for such electric vehicles? So, there will be slow chargers and fast chargers. Typically, at home and workplace, you will require a slow charger, and still, it is you will see that the power rating is still considerable because typically at our home we have this much unit. So, this much additional has to be added, which will also translate into fixed charges in your electricity bill as well. And the fast chargers can be used for highways and public locations which are directly connected to high voltage substations so that the distribution network is not disrupted. Of course, we are also seeing battery swapping stations which are emerging for different e-vehicles, and the distribution network, as we have discussed, is also going to need a grid upgrade. And so distribution network readiness, there will be tools required like smart metering, intelligent load forecasting system, the time of day tariffs. So time of day tariff is one of the thing that it is to be implemented when we have high excess energy at grid at certain times. We have high availability of energy. If you look at the power exchanges, then or you look at renewable power exchange like GDAM, you will see that sometimes the tariff of power becomes very low because the grid has excess of energy. So during those times, it is desired that our EVs get charged through REs. And then we'll talk about software infrastructure. So there will be intelligent apps that will be required for you to locate the charger location and how the booking and billing, what is the good time for you to charge your electric vehicles. So all these systems are have to be immersed so that our EV ecosystem can thrive. So if we are to study the effect on the grid for electric vehicles, then we have to do both type of study. One type of study is called as the deterministic study. So there is also an example that you want the substation to handle 50 electric vehicle charging at once. But there is also now a factor which is more random, which is called a stochastic study, which is going to be very instrumental during policy planning and forecasting. So it will depend on a lot of factors like what is the preferential time at which people would like to charge their electric vehicles, what is the time at which people would travel and what time they would like to charge their vehicles. So all these likelihood and probabilistic scenarios also have to be factored in to ensure the grid stability. So all these both these type of studies will have to translate into load forecast, which will utilities and regulators will have to do so that more and more EV can be done. Through these slides, what I'm trying to tell is that when we are thinking of electric vehicles, we should also think about our grid. So these systems and these practices should come as a natural consequences if more and more EV you want to see on the streets. So suppose there is a situation where people are randomly charging their electric vehicles. So random electric vehicle charging may have several negative effects. So we know from Ohm's law that V is equals to IR. So if high simultaneously charging is happening, then the current will increase, which will cause voltage drop across lines. So there will be decrease in voltage, and most of the people, if you are charging your electric vehicle in your home, then you have a single phase connection in your home. So suppose in one phase one EV is charging, in second phase no EV is charging, and in the third phase three EVs are charging. So what this can do is this can cause unbalancing. It can cause overloading of transformers and the cables. It can increase power losses because more and more charging current when it is drawn, then the I square R losses are going to increase over long feeder distances. It will reduce the reserve margin that the grid has. So if any unpredictable peak comes, then the grid may not be able to handle that. It will also increase harmonic distortion as these charger circuits also inject certain harmonic currents during different phases of their charging. So these are also some of the issues that can emerge when random EV charging happens on the grid. So this is in continuation of the previous slide. So we are looking at what are the harmonics challenges. So what happens during the constant current stage, there is lower distortion, but in the constant voltage state, there is a higher distortion. And random and uncoordinated charging can lead to unpredictable harmonic injection into the grid, and which can be difficult to manage because we are seeing that there are going to be diverse electric vehicle models and charger types. So this will cause an unpredictable surge in harmonics, and all these harmonics are going to interact. And it, of course, like also said, that home chargers which are single phase can lead to unbalanced loading. And transformer health can also, because it can cause overheating and overloading of the transformers and the cables as well. So the lifespan of transformers due to thermal stress can also reduce. There are a lot of studies on this also. So basically what this effectively requires is that we forecast our load. So if we are considering the distribution networks, then the DISCOM stands for distribution companies. So these are at the last level where they provide electricity to our homes. So they have to forecast and plan what will be the EV demand, and they need to plan for it. And they will have to design better and new tariffs for the people so that they can charge when the grid is available. And there should be incentives for green charging. Of course, this will require certain push from the government as well, and it will require upgraded infrastructure as well. As we already discussed, the bidirectional flow of energy which is going to happen when more and more solar rooftop is going to increase, and we want to source our RE more locally, then there will be bidirectional flow, and there will be more and more need of a smarter infrastructure at the distribution level. So forecasting approaches will have to be changed. Earlier, like we discussed, that the load forecasting was more and more deterministic. It was based on stable patterns. But with EV adoption, there is going to be stochastic elements which are going to be introduced. And certainly there are certain implications, like it can be difficult to predict the peak loads, and flexible grid operations and smarter forecasting systems will have to be there in place. And so let us briefly discuss what are the complexity drivers when we are discussing electric vehicle loads. So it will depend upon the consumer behavior, the travel and fleet movement patterns, the type and location of charging infrastructure, and the different pricing and incentive structures that are going to affect the charging times. So certainly this is a great opportunity for all future engineers, so that they can help in such. See, every problem presents with it opportunities, and these are such opportunities which the future engineers must consider, so that they are adept at meeting the challenges and the requirement of the current system. So next, this is a very popular concept called as vehicle to grid. So basically, we discussed that our solar rooftop can also inject power into the grid. But what happens, suppose that my electric vehicle is plugged into the charger and it is drawing energy for charging, but at the certain times when the grid is in need of power, then there is reverse flow happening. That is, my electric vehicle is putting energy back into the grid because the grid is in time of a crisis. So such a concept can be actually implemented through this concept, which is called as vehicle to grid. So here what happens is your electric vehicle battery will convert into a storage for the grid. So it can offer a lot of services, a lot of help to the grid, like frequency regulation, voltage support, and providing additional reserve margin for the grid. And it can act as a distributed energy resource in itself. So there are certain pilot projects that are also happening, and there are also certain standards in place regarding our charger inverter requirements, and also the communication protocols that are going to enable the intelligent control and the tariff negotiation between the electric. So there of course will be a tariff negotiation between the electric vehicle and the grid. So you are putting your energy into the grid, so certainly you must also get paid, right? So, so such systems are also going to develop and put into practice when electric vehicles are going to come. So when we look at our charger, say our mobile charger, so we imagine that there is only going to be a one-way flow of energy, right? So if put my charger into a socket, so the power is going to flow from the socket into my mobile or into my laptop. But for electric vehicle charging, it is going to be different. Yes, you can charge your vehicles, but you can also do a lot of other things as well. So this is where the smart grid applications of electric vehicles come into place. And as more and more electric vehicles come into circulation, then at such time, such categories of application will also be needed. So you can see that let's briefly discuss. So there can be congestion management, voltage support, behind the meter optimization, load leveling, frequency regulation, inertial support. So what happens is, as also the more and more renewable energy is going to supply to the grid, the inertia that is offered to the grid by the renewable energy is very low. So these batteries can provide necessary inertial support to the grid as well as more and more renewable energy penetration happens. So frequency reserve, voltage control, and they can also help as a storage systems for our renewable energy sources as well. They can act as storage for our rooftop photovoltaic as well. So this is open to a lot of innovation on our end, and we should as engineers explore these options and uh, think of ways in which our EV chargers can also interact with the grid so that it benefits the grid stability as well as uh, the return on investment that you get from your electric vehicle. So certainly there are some grid related opportunities when it comes to electric vehicles. It can be shifted at the load can be shifted using the renewable energy, and it can create self-sustaining microgrids, and you can have solar power charging along the highways. So so it can help in decentralized renewable energy generation so that it reduces transmission losses and our grid congestion as well. Of course, there is blockchain-enabled technologies which can also be implemented when it comes to charging our EVs. So it can also help in ancillary services. So what you cannot use your own vehicle for ancillary services because they generally have a minimum bid volume. So electric vehicle cannot participate as a single entity, but an aggregator, like earlier we discussed the concept of a group of fleet of EVs, right? So they can participate in the ancillary service markets to provide services to the grid. They can act as a mobile storage unit to benefit grid operators. Now let us discuss from a practical point of view what are the challenges for you for having more and more distributed energy resource for charging our electric vehicles from a distribution company, our DISCOM's perspective. Right. So first of all, we will discuss this point number two. So first of all, we need to know a concept of cross subsidy. Basically, what happens is that certain uh, portions of the society, they get electricity at a very cheaper rate, like our farmers and other members. So the difference on the electricity price is usually recovered from the consumer and industrial uh, consumers of electricity. So this is called as cross subsidy. So what happens if more and more people start to install their own rooftop, their own renewable energy? So naturally their electricity bill is going to decrease, and as a natural consequence, the revenue of the discom is also going to decrease. So it can also lead to certain situations when, because of net metering, the discom has to pay. Suppose that you generate more electricity than you actually consume. In that case, the discom has to pay you for the energy that you have injected into the grid. So it will naturally lead to um, a sort of decrease in revenue for the distribution company. So they may start discouraging rooftop and open access through imposing more charges and restrictions. So this is a financial impact on discoms which will emerge, and this is very practical also. You have to just think that you are in the shoes of the discom. And of course, like we earlier discussed, bidirectional power flow, it is going to need a upgradation of the facilities in a very humongous manner. So, so who will pay for such grid infrastructure which needs to be strengthened? Who will pay for the deployment of smart meters and smart grid technologies? So, and different technical grid studies that are required. So these are certain challenges which are going to emerge as more and more distributed energy resources are used for our electric vehicles. And of course, there is also certain policy gaps like time of day tariffs, green tariffs, they are not yet implemented across states. And uh, using such time of day tariff can incentivize charging during the RE rich hours. So when the time like the sun is up, the solar panel is generating, at such times the charging of electric vehicles should be incentivized. And at the time, like you, if you refer to the duck curve, the times when the load is high, at such times charging of EV should be discouraged. So such different time of day tariffs are yet to be implemented, and there is lack of subsidies for smart and bidirectional charger deployment. Actually, if you see in the news, you will find that the discoms are facing a lot of losses. So this is a practical constraint in the deployment of electric vehicles, that the necessary infrastructure will require certain support also. So finally, we'll discuss some ideas on green open access. So what is green open access? Now we have seen that there is a lot of constraint on the part of our discoms. So what we can do is we can allow large electricity consumers which have load greater than 100 kilowatt to directly procure renewable energy from a generator, and they can bypass the local distribution company discom, and this is enabled under the green energy open access rules, so that the RE adoption can be boosted. And EESL, Energy Efficiency Services Limited, is also piloting some projects wherein the RE for EV charging is directly procured. So, so this is also one of the concepts which is worth knowing. So where there are certain ideas on how to design the tariff for renewable energy, the time of use tariffs, the dynamic pricing on how it should be the prices at different type of the grid conditions, and there should be different prices for fast charging and slow charging, and should also be smart charging initiatives like vehicle to grid enabled systems which optimize the grid usage. So there should be incentives in place also. So what are the measures through which we can improve the electric vehicles effect on the grid? So first of all, there should be no random charging. There should be coordinated charging of electric cars, which will require a sort of aggregation models. Maybe you use apps, mobile apps, so that you know what is a good time to charge. The chargers for the electric vehicles should have power correction, and especially new chargers with new technologies should be used. And older model of chargers which introduce a lot of harmonics, they should be avoided, or maybe they should be replaced. There should be filtering techniques and advanced control algorithms to limit the harmonic distortion. And you should also use converter topologies which are more closer to the sine outputs. And finally, there should be communication protocols and algorithms which can be used by intelligent charging solutions to optimize grid charging schedules. And also using the vehicle to grid idea, that is also going to improve the grid's performance. I think we can skip this. So some additional points are the use of artificial intelligence and machine learning in predicting EV loads, because sometimes through supervised learning you can achieve maybe a limit. There is a limitation on what you can achieve through supervised learning, and with the recent successes of uh, AI in the terms of GPTs. So we are seeing that you let the machine learn by itself, and it can tell you a lot of interesting things as well. And deploying more and more uh, impactful simulations like digital twins for our substations or our trans and different components that are there in the substation. And yeah. So that's it. This was probably the most lengthy part. Now we will go to the module 2, where we will briefly discuss what are the domestic policies, what are international policies, how different countries in different continents are pushing uh, EV adoption, and what are the other emerging policy dimensions which are not in place right now, but they are certainly expected to come in the near future. So, just to have some interaction, if there are any doubts, I will be very happy to answer them.
Good afternoon, sir.
Ji.
Sir, I have a doubt that can battery swapping is as much as faster as the refueling petrols? Because in the petrol pump there is a infrastructure also about refilling the petrol and move from there in a 5 minutes. But battery swapping is that much easy.
See, of course, it will be done by professionals. It can take 10 minutes or maybe say 15 minutes, but still it is better compared to. See, one of the limitations of EV is its charging time. So the charging time is considerably large for electric vehicles. So, regarding your question that can it be as fast as petrol filling? So there are other factors also. So, how long are you standing in the line to get your chance at the refueling station? That is also going to matter. So it is also a matter of management, right? If your swapping station is better managed, so maybe you can have your battery switched in no time, and on the other hand, at a fuel refilling station, you might be standing in a long queue to get your turn. So, like, of course, it depends on other factors as well.
Sir, so there may be the chance na the energy distributor may get into loss because in case of battery swapping, when we are doing it for a one time, then we'll pay for the one time charge. But the consumer may go to the home and use it for recharging day by day and deteriorating the life. And after the long period of time, it will give to return and give the pay of only one charging to the energy operator. So this is the case of loss for the energy operators.
Maybe,
Sorry,
but
distributor.
if you use your laptop, you can also monitor the battery health of your laptop through running some simple commands in the CMD prompt. So, of course, when such swapping ideas are in place, then there will also be certain use cases where they will also check upon the battery health. And you do not get to keep the battery for yourself, right? So eventually you will have to swap it, or so yeah, that is an interesting area where we can look into. But certainly, if you are swapping batteries for say e-rickshaws, then all these e-rickshaws maybe they have certain way of charging a different charger. So
Sir,
I get
there
your
is the
point that
chance that we are
somebody might
using.
use keep the battery, a good battery, a new one, and he gets to keep it now. It's like, am I getting it right?
Okay, sir. Okay, sir.
No,
Sir,
this is what you were asking, right? Ki,
sir, I am asking that if we are using na, if we are using the battery, we borrow it from the energy distributor and then use for a one-time that we pay for the one-time charging na. But we keep
yes,
it in a home and use day by day, charge and recharge. It may deteriorate the life, and we will pay only the one-time charging fee na.
okay. So maybe the person who is running the swapping station will have certain mechanisms in place. Such misuse does not happen. But then for
Sir, there will be
to
chance that we
explore
can
this
use
in more
battery
detail.
locking structures.
Okay, okay, that is. So I'll have to look into this. I'm
And Pratik, I just
Yes, sir.
want to know what exactly you wish to know.
Sir,
What
I
is
just
your
wanted to
question?
know that. Sir, I just want to know that in our country that if we are borrowing the battery from the energy distributor, na, so after a period we'll pay the one time fee for the charging, but we'll keep the battery in our home and charge it day by day. So it may deteriorate the
See,
life, na. So it may get. Uh,
listen, you
yes, sir.
have purchased one battery that is charged. If you use that, it will they get discharged. To again charge it,
Yes,
you have to give supply to this,
yes,
and
sir.
again use it. Where is the problem?
Sir, in battery swapping session, we not buy the battery, na.
Battery,
We just
see, yes, in battery swapping system, they have several battery which are charged. You just take the
Yes,
example
sir.
of refilling gas cylinder. We take one
Yes.
cylinder, gas cylinder, we use it. Once
Mhm.
it is empty, we will replace. As simple as that. Because the charge, or you can say the gas which is inside the cylinder or the charge inside the battery, that is fixed amount of electricity. Whether you use it today, tomorrow, or day after tomorrow, it is up to you. But the amount is fixed. So once it is drained, you have to give it back to them, and then again you have to purchase. If you wish to, that is another thing. If you take a battery and wish to charge at your end, that is different configuration. It should not be related both two things. There are charging station where you can charge your battery. That is the one solution. Other is the battery swapping station. You just go and replace the battery so that the time is saved. Right?
Okay, sir.
That is the phenomena.
Yes,
Ankit,
sir.
am I right?
yes, but still it is a very good thinking on his part that how a battery should not be misused, right? So it could cause a lot of loss to the battery swapping operator if people start taking his batteries and start using it as their own.
No, no,
So
they can use it, Ankit. No problem at
yes,
all. See, batteries are safe. Batteries are same. If you wish to charge at your end, you can do this. But the swapping is involved just to reduce the time, just to
Time.
save the time. So it is the optional. It is totally optional. If you wish to change the battery and get it now, like we go to that diesel station, petrol station, they refill our tank. Likewise, they will have battery, and we will go there and change our battery. And if you
सर
don't want to,
मैं
yes,
जो समझ रहा हूँ ये कहना चाह रहे हैं कि सपोज मेरे पास एक बैटरी है और मैंने
uh-huh.
उस बैटरी को अपने घर पे चार्ज कर यूज करके उसको एकदम खराब स्थिति में ले आया हूँ और फिर मैं
भाई
बैटरी
आप
स्वैपिंग स्टेशन पे
समझिए,
गया और
बैटरी अगर आप अपने एंड पे यूज करेंगे, चेंज करेंगे, तो देयर इज यू कैन नॉट, इट इज नॉट लाइक दैट कि you take good battery from there and they give them a damaged cell battery. They will
हाँ
check it. There
यस
is
सर वही मैं कह रहा था
there is ordinance is there, right? Restrictions are there. They will
you
check the
can check the health of your
otherwise
own laptop battery as well, right? You can check your the health of your laptop battery through certain command prompt instructions. So of course such mechanisms will be in place
before
to,
swapping they will check the battery, then only they allow to swap the battery. It is not like that you can give any condemned time battery to them,
yes.
right Pratik?
Okay, sir.
I hope that your doubt is cleared, Pratik.
Yes, sir. Okay, sir.
Uh, Dushyant, we have questions from Mr. Dushyant and
क्वेश्चन नहीं था। गुड आफ्टरनून सर। सर इसी चीज पे जो प्रतीक पूछ रहा था उसका ये था कि ऐसा भी तो करा जा सकता है कि
Dushyant,
चार्जर स्पेसिफिक बना
Dushyant,
दिए जाएं। हाँ सर।
Dushyant,
यस सर, यस सर।
this is not the discussing panel.
ओके ओके,
Ankit
सॉरी
Saab is expert. If you have question, you can ask. If you want to discuss something, we are free to discuss for 24 hours. You can talk to Ankit sir as well as me. So this
सॉरी
is live and it is not for discussion. If you have any query, you can ask to our expert. That's it.
अभी क्वेरी तो नहीं है सर कभी कोई।
Then
okay,
speak.
thanks.
Any
And
other query?
any Shreya ji, do you have any question?
Yes, sir. Good afternoon, sir. Sir, I have a question regarding sir, how much sustainable these electronic vehicles are? Because electricity is also made from the natural resources, and diesel and petrol are also irreversible sources. So, how much EV are sustainable?
So that we will discuss. We have already discussed this in the previous slide. That if you rely solely on the grid, then there will be certain emissions which will be associated with your electric vehicle. However, as the renewable energy is increasing, the grid is being more and more green. In certain economies like Norway, the whole economy runs on renewable energy sources. So one of the answer is maybe as our grid becomes more green, then you can use your vehicle directly, charging directly from the grid. And the other thing is that you can use RE for charging fleets, and there can be tariffs for using renewable energy. So in previous slides, we discussed various models through how we can use renewable energy for our
Yes, sir.
charging. So, of course, if you are using only the coal-based or thermal-based energy, then there will be certain emissions which will be associated with it. And in the module 5, we will discuss what are the environmental impacts as well. So, if maybe you can uh, get your answer query, can get your answer when we reach to module 5.
Yes, sir. Thank you, sir.
Thank you, thank you. So now let us start again with module number 2. So now we are looking at the policy landscapes. So why policy matters? Policy matters because electric vehicles have been expensive than the internal combustion engines. So it requires certain push from the government so that more and more EV is adopted. And we also, India has a huge oil dependence. 85% uh, of the fossil fuels what we get, we import it. So India is dependent on import for majority of its fossil fuel needs. So this is can also be an initiative under Atmanirbhar Bharat, that we use we use the energy that is available to us. So India is blessed with abundance of renewable energy. So how about we use renewable energy for meeting our energy needs? And also there are certain areas like Delhi NCR where the pollution is considerable. The AQI is very poor. So maybe to cut emissions, electric vehicles are promoted in certain cities, and it can also be it can also be a sector EV where it provides make in India opportunities. We can boost our domestic manufacturing, and we can also use innovation. So, so there are many policies which influence electric vehicles adoption as well. So the prominent ones are FAME, it is faster adoption of and manufacturing of hybrid and electric vehicles. So all this information is usually available on their website and other platforms. So this is an indication of the FAME which was used by the Department of Heavy Industries for to promote manufacturing of electric and hybrid vehicles. And then the current scheme is FAME 2. So it has a significant outlay of 10,000 crores. So it has emphasis on public transport, shared mobility, and there are subsidies for e-buses and two-wheelers, three-wheelers, fleet cars. So there is focus on charging infrastructure as well. So charging station is one necessary infrastructure that is required for uh, a good amount of EVs to be deployed. So this is FAME 2 scheme. Then there are other schemes like PM e-bus Seva scheme, which has deployed about 10,000 e-buses in 100 cities. And there was a scheme called as PLI for ACC scheme, which has now been renamed. So this is one of the most popular schemes in which we are incentivizing. So a PLI for ACC batteries. So we are incentivizing. So one of the factors in the scheme is the domestic value addition. So the more and more domestic value addition is there, the more and more incentive you get. So such incentive schemes are uh, formulated by the policymakers so that more and more domestic battery production can happen. And of course, we would also like to reduce our dependency on imports, especially from countries like China. So there are also different state policies as well. Let's talk about Uttar Pradesh. So one thing you will notice in Delhi that most of the vehicles which are hybrid vehicles or electric vehicles, they have a Uttar Pradesh number plate because Uttar Pradesh in Noida, is also comes under Uttar Pradesh. So there is 100% exemption on both registration fees and road tax. So which translates into a considerable savings. So there are full waivers. They're like on EV purchase and registered in the state. So this ends this year on October 13 exemption period. But still there are other waivers which will taper down. So such incentives are also put in by the government, state governments, so that uh, electric vehicles and other hybrid electric vehicles can be uh, incentivized. Then there is Central. This is one of the latest news in which import duties on EV cars has been reduced from 110% to now 15%. So it is generally viewed as uh, maybe a way to invite Tesla, but there is also uh, one clause regarding the investment that the electric vehicle manufacturer has to make. So, of course, these are certain policies which also boost the adoption of battery electric vehicles. Then in Europe, they are penalizing fleet emissions. So recently, what you will see in Europe, I was there in Rotterdam. So basically what they are doing, there is more and more EV on the streets because they are taxing uh, ICE engines and they want to reduce their emissions. So there are different policies like EU Green Deal, Fit for 55, where they are providing uh, purchase subsidies and tax breaks for electric vehicles, while at the same time they are penalizing emissions. So this is one way of you know penalizing the pollution vehicles and incentivizing the electric vehicles. So there is also the Make in India perspective, wherein the key minerals that are used for batteries like lithium, cobalt, nickel. So we are basically import dependent on these. So you must have seen in the news that lithium reserves have been found in Jammu and Kashmir, and also we are also working on securing overseas mines. So there is also government push to have our own materials, and schemes like PLI, ACC schemes, or which can incentivize domestic battery production. And we are also exploring different uh, alternatives to lithium ion batteries. So let us talk about the additional emerging policy dimensions. So a carbon market is yet to be established. It is one of the limitations that India has not put it in place, but the carbon credit trading scheme should be there now so that additional benefit you can also get from using electric vehicles. And of course, there there has to be policies in place so that there are standard regarding what kind of connectors that you can be used for your charging your electric vehicles, so that uh, in the larger picture, vehicle to grid like concepts can also be put into practice. So this was regarding module 2. If we have any doubts, I'll be happy to answer them. No doubts, I think. So let's move on to the module 3, which is regarding the economic trends. So here we will discuss what are the decline in battery costs, what is the global market growth, what is the cost of EV falling, and maybe case studies on countries like China and Norway, which are adopting different approaches towards developing their EV economies, and what are the economic impact as more and more EV come into play. So first of all, let us discuss the decline in battery costs. So the battery costs are reducing year by year. In 2010, the battery cost was more than 1100 US dollars per kilowatt hour, and by 2025 it is around $130 per kilowatt hour, and it is expected that soon the 100 US dollar uh, it will be lesser than the 100 US dollar per kilowatt hour as well. So this is one of the driving factors, and it is one of the reasons why also regarding our power system you are seeing more and more tenders on BESS, battery energy storage systems. Because of this decrease in battery, you are seeing more and more battery solutions which are also being deployed for the grid as well. So regarding what are the reasons for the drop in battery prices, so China is spearheading the way when it comes to mass production of batteries. So and different battery chemistries advances are also happening. There are more and more global players which are coming into play, so like BYD. So they are also increasing the competition for companies like Tesla, and there is also government support by different governments regarding R&D funding and infrastructure investment to promote faster deployment of battery systems. So when you look at the global market growth, it is very impressive. it is around like 30% depending upon the market scope. So the CAGR is very impressive for electric vehicles. There are different kind of electric vehicles: uh, battery, plugged-in, two-wheeler, three-wheeler, commercial vans, buses, trucks. So, this is also, there is a great deal of diversity. Uh, there are a lot of e-rickshaws also, like in Delhi. So there are different segments, and these segments, it depends upon the components, but still there is a lot of segments when it comes to electric vehicles, and the market share scale is also increasing. So the cost of EVs are falling because because there is a lot of competition and different battery chemistries are also developed. And soon we will reach a point when the electric vehicles will become at this will be available at the same cost as the internal combustion engine vehicles, even without subsidies. So this is the time when the earlier discussions that we had regarding power systems perspective, so it will become more and more real when the EVs will reach cost parity with ICEs. So there will be a lot of pressure on power system engineers to develop systems that are foolproof, considering more and more EV penetration. So China makes up about 55% of the global EV scales. uh, these are certain facts and statistics regarding the EV battery innovation and the subsidies that China is providing since 2009. So China's strategy is basically to it is seeing it as a way to advance their technology to provide more and more people with jobs, and to spearhead innovations in AI, robotics, and automation. And also, if you see that the AI requires, sorry, the electric vehicles require a lot of management. There is when we think of when we study OOPS, object oriented programming system, in you must have studied in first year. So you see they give the example of abstraction, that when you are driving a vehicle, you just have to think about steering the wheel, and putting in the brakes or putting in the accelerator, and you do not have to think how the ICE, internal combustion engine, is working. So it is shown as a level of abstraction. But the electric vehicles have more finer, control points, which is why if you think that um more and more self-driving cars, they are all electric vehicles. So maybe, I do not know, it is a food for thought, that maybe you know uh, artificial intelligence or machine learning is better at driving cars, especially when it comes to electric vehicles. So of course, this is one food for thought. So next is Norway. So Norway has abundance of hydropower, so uh, they have like the grid is almost green, and they have like impressive range of new passenger cars being electric vehicles. So you can see that almost all of the cars in electric vehicles in Norway, and they want to end the sale of new petrol diesel vehicle cars by 2025. So regarding your questions on how sustainable EV are, but when it comes to Norway, since their grid is so green, so their EVs are also green. But still, there is one point regarding the emissions which happen during the production of electric vehicles, particularly their batteries, which we will discuss later. So there is also considerable economic impact when it comes to EV. It is a growth engine. It creates a lot of jobs, and these EV technologies that we develop, they will translate into various different fields like algorithms and semiconductors and even thermal management systems. So like when you develop a space mission, and the technology also gets translated into various applications here on Earth also. So uh, now, as we are seriously making our minds to transition to electric vehicles, okay, so there should be also consideration on a sustainable transition from our traditional vehicles to electric vehicles. So there are certain facts about our traditional vehicle industry. It is a significant contributor when it comes to our GDP, our manufacturing GDP, on how many peoples that are employed by the traditional combustion engine vehicle sector, how much it contributes to our exports. And so uh, these facts are, you can see on the screen. So it has 7.1 contribution when it comes to the GDP. It provides employment to like 3.7 crore people. So this is a considerable portion. This is a considerable industry that the EV is seeking to replace. So if EV disruption happens, then it will result, there are risk of job loss in traditional automaking. There will be new roles in the EV domain for power electronics, for software, for infrastructure. So their government and industries must prepare so that this transition and is sustainable, and there is adequate reskilling of the workforce. So this is one of the social impacts of uh, transitioning to electric vehicles. And let's talk about the running cost advantages. So basically, your charging cost will be around 2 rupees per kilometer, whereas your diesel cost can be around 10 rupees per kilometer. So there is a saving, there is a considerable saving considering the operation of the vehicle from going from point A to point B. So as you can see, there is this news article on cost comparison of Tata's Nexon. So if you run it for 1 year or 15,000 kilometers, so petrol costs 1.2 lakh, diesel costs around 96,000, whereas electric cost only like 15,000. And so this is uh, like running cost advantage of EV. They have fewer moving parts, so there is no engine oil replacement, no clutch system, there are fewer filters, no oil changes, spark plugs, timing belts, and they, it is also further helped upon by government incentives. So next, so any questions on module 3? Oh, so great. So we'll move to module 4. So I know that Sanjeev sir is going to cover this topic in great detail. So so I'll just basically mention what are the components of electric vehicles and what they do. So basically, first of all, there is the battery pack which stores the electrical energy. It is in DC. Then there is inverter. Inverter, actually what happens is that the motors that are used in electric vehicles, they are not DC. AC is preferred over DC. So the motors are AC, so you need conversion so that the DC from the battery can be converted into AC. So that is the work which is done by inverter. And then there is the electric motor which converts electrical energy into mechanical, and this moves the vehicle. And there is DC to DC converter also. So sometimes maybe you need to run the auxiliaries like fan or maybe AC, and they can be step up or step down as well. So different DC to DC converters are also there. So these converters you will study in power electronics. And then there is onboard charger which converts AC from the charging station to DC, and this is fit into the electric vehicle also. And then there is motor controller and battery management system. Basically the DC-DC converter which converts the battery voltage from high voltage to the required voltage level, and so so it also provides a degree of isolation as well. And then there is inverters. Inverters can be thought of as the brain behind the motor. Depending upon what the signal the inverter is giving to the DC motor, it will control the speed and the torque by changing the frequency and amplitude of the AC it provides to the motor. And it also supports during the regenerative braking. Then voltage source inverter is the preferred. Uh, it is actually more common to find in the electric vehicle. Then there is the onboard charger. So it can support vehicle to grid. So it is part of enabling the smart energy management features. And you can find different levels, typically ranging from 3.3 kilowatt to 20 kilowatt. It depends on the vehicle or what is the charger capacity. Then there is the battery management system. It looks after the battery, it monitors each cell for the uniform performance, and there is connection with the inverter and charger as well. So this is also very essential when it comes to the safety regarding electric vehicle. Then finally motor. So there are different type of motors that are used, predominantly AC motors. So for heavy duty vehicles, induction motor is used, and for light cars and EVs, BLDC and PMSM motors are used. And then there are also applications regarding AI in the EV. So there can be applications for AI in terms of battery management, driving autonomy, self-driving, smart charging, predictive maintenance, and behavior-based settings, and fault detection and quality control. So finally, we come to the last module for regarding environmental and social impacts. Here we will discuss the emissions, the waste management that are associated with electric vehicles, road safety, and other social factors. So, of course, there is significant improvement in the air quality in the urban centers where electric vehicles are used. So, in areas where there is very poor AQI, using electric vehicles can certainly improve um, the AQI. And when regarding when emissions, when grid is coal dominant, so of course there should be certain policies in place to ensure that renewable energy is used, so that our electric vehicles are truly, they have zero emissions. Next, we will talk about the production emissions. So basically, electric vehicle during its manufacturing stage, primarily due to battery and material processing, it has a certainly higher emission than the internal combustion engine. So, but this carbon debt is often offset when you drive your electric vehicles for 44,000 to 70,000 kilometers. So then there is a parity reached between the production emissions or the overall emissions of EVs and ICE. So of course there will be certain innovations in time through which we can reduce the production emissions of electric vehicles as well. But of course, there are considerable production emissions when it comes to electric vehicles. So the batteries used are lithium-ion batteries, which which reach their end of useful life when there is more than 20% degradation of their capacity. So they are hazardous and major waste, and this is a serious environmental concern. And they have also the potential to overheat and catch fire. You can see sometimes you see on the news that electric vehicle has caught fire, and when it catches fire or when it is exposed to extremely high temperature, it emits poisonous gases like hydrogen cyanide and carbon monoxide. So Of course, there should be steps in place for recycling of the batteries. There is also a use case for using cascade utilization. Maybe the battery, if it cannot be used for electric vehicle, then maybe it can be used for storage for the grid. Maybe it is used in stationary storage applications. And there are also very R&D efforts going on for ultrasonic recovery of active materials, so that the precious rare earth materials that are there in the electrodes, they can be extracted and reused and recycled. So also these critical minerals that are used in the electrodes, their extraction is highly energy intensive. So another factor is EV weight and vehicle dynamics. So EV has a significant weight because of the heavy battery packs, and because of tire wear, they can have particulate matter emissions more than 3 to 8%. So also EV moving has a higher momentum. So basically the impact, the crash can also lead to significant risk to the pedestrian. Also, there is also a risk of that the damaged battery cells can trigger fires. They can lead to fire risks, and the heavier vehicles also exert more stress on the road. So it also increases the maintenance regarding the roads as well. So the crash test ratings for authorities are revisiting testing norms to account for higher electric vehicles, because the whole crash dynamics changes because of the weight of the electric vehicles. So of course, in earlier times, there was a lot of social concern regarding range anxiety. It is also one of the things that come to mind when you are considering buying electric vehicles. But still, there are improvements in range which are happening, and with time, the range anxiety regarding concerns will also be taken care of. So finally, we have reached the last points of the slide. So basically, these are the skills wish list. So this electric vehicles presents a unique opportunity for upcoming future engineers to contribute to this sector, and there are exciting roles. So basically, there is power systems, there is battery BMS expertise, power electronics and motor control, grid infrastructure and standards, software, energy management systems, AI related, and thermal management integration, cybersecurity, analytical testing skills, and project management skills, and regulatory knowledge as well. So these are certain EV companies. Of course, Indian EV company manufacturing is also there. So EVs, and maybe the training and placement cell can invite such companies for placement as well, uh, for for career opportunities as well. And so I think this is the end of my slide. So if there are any questions, I'll be happy to take them.
Good afternoon, sir.
Good afternoon.
Sir, if you are looking at, can